No, I only gave you one. This was a easy start. I can, actually. Jesse's a great pickleball player.
Yeah, but Ripplinger's not.
Are you talking about her? Mr. Roberts, right?
I've never seen Jessie.
I bet she's a baller.
Are you a baller?
Ericksons are usually humble, unlike Bennett's. All right. We ready to do this? It's an ever-evolving process.
Your pocket makes me so happy.
You like that?
Beautiful.
Well, I started with an iPad, and that was just a pain in the butt. Moved to the phone, that was a pain in the butt. Well, technically, I started with a phone, but it made my pocket too hot. How many? One of my favorite words in chemistry. How many grams of magnesium oxide can be formed from 60 grams of Mg? Let's see. Take that light off. All right. So I didn't feel like rewriting this from last year. So I just, oh, you got to be kidding me. I selected that thing. There we go. Who had 99 point something or 100-ish?
Yeah.
Who thinks this slate needs to be burned and returned to whatever volcano it came from? Me. I do. Okay, so just double check that you did the same thing I did. You had 60 grams to start. We want to get rid of grams, so we bring them down. Then we had moles. Anytime you write grams, you have to write it per mole, correct? Except in the given. All right, so I have per mole of Mg, mole Mg came down, mole MgO went up top. Mole MgO, 40.3 grams of MgO. 100 grams, or pretty dang close. Or 99.5. All right, are we okay with this? All right. So, can you see why we spent a while on balancing reactions? If you can't balance a reaction, you can't really do one of these at all. Okay, this is a decomposition reaction, and it's an example from last year. We took a solid of metallic chlorate. When they decompose, they go to metallic chlorides and oxygen. Not super hard. We did a demonstration. I did a demonstration just like that. Correct? What did I do? Do you remember? What chlorate was I using? Potassium chlorate. All right, potassium chlorate. We did the exact same thing, and we did that exact same substance. Okay, I want to. Oh gosh, dang. This thing. Hold on. Ever since yesterday morning, it's been behaving very badly. Look, I'm not even doing anything right now.
Creating a barcode.
It looks pretty good.
Maybe if we scan the barcode, it'll give us like a secret website, and
Probably.
then we'll be Indiana Jones.
It's probably binary for a code that will make us go back in
Is it
time.
binary or just binary? People keep saying binary, and I'm pretty sure it's binary.
I don't actually know. That's a good question.
I'm pretty sure it's binary.
Well, this is a ton of fun for me.
Offended by your duct taping skills.
It can't be offended by my duct taping skills.
Duct tape it?
I duct tape something to the back.
I don't like it when people duct tape things to my back.
Good point. Thank you so much. All right, let's pick up limiting reactants from here if it will let me. Here we go. I got this. All right, so let's review limiting reactant. We said we're going to give you 2 amounts, and you figure out how much of the other one. Are we ready? That was a little bit harder. So we have 27 grams of Na. Let's say we have 35 grams of oxygen. See if you can calculate the mass of Na2O left over. The way the test question would work, it would ask you to identify the limiting reactant. Okay, we would want to know just what it is. We would want to know the mass of product. Yep, always based on which one is the limiting reactant. And then we're also going to know the mass of excess reactant. I want you to think it through and figure it out yourself. I know you can. Oh. Oh no, that's what got me in trouble before. Okay, let me walk you through everything we just did. First, we balanced the reaction. Was it already balanced? Oh, crud. Crud. Something is wrong with the scrolling bar today. So, I know how to do it. I got this. There we go. All right, it was not already balanced for you. So what will we need to do? Put at least a 2 right there, right? Anything else? Put a 2 right there. So I screwed up my own rule, didn't I? There's a 4 right there, is there not? Sorry. Should have balanced oxygen, or the Na. Yeah, the oxygen first. All right, so 4, 1, 2. Who had that? Raise your hands. Okay. I don't dare scroll, or we'll try it. Nope. All right, so we balanced. We make 2 picket fences to determine the limiting reactant mass and mass of product. And then the last thing said use LCOM. Do you know what that even stands for? All right, law of conservation of mass to determine your excess. So I can't scroll down, so I'll just add a new page. No, yes I can. All right, so you had 2 picket fences. Just tell me the answers to one. When you started with Na, what was your mass of product? 36? Who agrees? Who says 30 something else? 39? Okay, fine. We can certainly do it. 27 grams of Na.
Wait, what are you looking for, the grams?
If I start with 27 grams of Na, how many grams of Na, whatever we're solving for, am I making? That's what I'm looking for.
Windsor agrees. I don't agree. I agree with you, man.
This is where I got confused.
That should be 4.
Oh, yeah, don't you have to times that by 4?
That should be
No.
4 moles of Na.
Not yet.
The bottom right should be.
No.
Yeah, the bottom right should be 4.
We'll get there. This is just 23 per 1.
Right.
Anytime you get something from a periodic table, which this was,
Per 1 mole.
it's per 1 mole. If you put a 4 here, then you're going to be all sorts of jacked. I know where the 4 goes. So down here is where you have your ratio of coefficients, and that's where it's mole per mole. And it's mole of what I have to mole of what I want. So what was in front of Na? What was in charge of, or in front of Na20? 2. And now I come down here, and this number's a 1. And 62, what is this? 62? So I'm going to reduce this to 1/2, just because that will save me a step in my calculator. So 27 times 62 divided by 46. Who has 36.3? Raise your hands. Oh, you got to be kidding me, machine. Where are we at? Now I've lost my cursor, so things are going to be in the wrong place because I just have to guess. 36 point what? 39. All right, we still have to make a second picket fence since we got in an argument. Jesse, does this make more sense to you now?
Yeah, it actually makes sense.
Okay, what was the other starting thing? This will be a joke. 35 grams of O2. This is going to be so fun. 32 grams of O2, right? Per 1 mole of O2. Then what was in front of O2 in the balanced equation?
So say you did just O, and you did 16, but you put a 2 right here, it's the same thing, right?
If you screw up the right way twice in a row, you'll be fine. What was in front of O2? A 1. What was in front of Na2O? All right, 1 mole Na2O. We already said that was 62 grams Na2O. Okay, so we math 35 times 2 times whatever. What am I going to end up with? 100 and something, right? Okay, which weighed least? The one up top. So this right here, make sure you don't put Na2O.
Today, right now is a good time to say it's on there.
Yeah, it is so jacked up right now. 1 second. So Na must be my what? Limiting reactant, which means this stuff right here means nothing to me, right? My massive product must be this then, correct? All right, yes.
So when I was looking at the original equation, can you just look at it and see which one it is?
Sometimes.
Okay, because I kind of did that, and then I was like, wait, is that wrong? Or?
You just got to be a little bit careful because you got to remember it's in grams and it's, so you can almost figure out the moles, but there's also balance. But this one was supposed to be a little bit obvious. And about half of them you can figure out in your head before you move on. All right, now, the last step, yeah.
So why is it 2 on Na? Why is it 2 over 4?
Because I had
You gotta look to your balance reaction.
Na plus O2 goes to Na2O, right?
Right, and you have a 4.
Okay, I got to double this to take care of that. I put that here. So this 4 is what is in front of Na,
Yeah.
and that 2 is what is in front of
So
Na2O.
it's not 4 over 4. You don't take the subscript of Na.
No, 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 no. Don't take the subscript because it's accounted for right there already. Okay. All right, now, so if we have 36 grams of product, the law of conservation of matter says that what I start with, I have to end with. So I had 27 grams of Na and I had 35 grams of O2, right? I'm going to, like my original things that I gave you were those two numbers, correct? So 27 plus 35 is 62, is it not? So I have 62 grams to start. I have to end with what? 62 grams. So if I made 36.39, I just subtract that from what I started with, 36.39, and that will tell me my excess reactant. And I don't know, 27.61.
So pretty much all you're doing in these is, so you don't like minus them or anything. You just pretty much find the lowest one. That's the limiting reactant. Take your excess reactant from your answer and then minus that.
Pretty much. Now, it gets way more complicated in Chapter 4. Be excited. All right?
Finish chapter 4 before midterm.
Definitely not. Chapter 4, we're going to spend like 3 days on 3 total problems. Sound fun? We have to be very good at this before we can do that. All right. I feel like we should probably do one more of those. Let's do a combustion reaction. Let's see, and I'll write it out in a minute, but if I told you that propane, well, how about 50 grams of propane react with 50 grams of oxygen, how much CO2 will you, whoops, there's supposed to be a space there, whatever, produce? Okay, so MEPB, then remember geometry. MEPB, then remember geometry. Does everybody already give up? No. C3H8 plus O2 always makes
Carbon dioxide and Mars. I know that part. You're gonna have to figure out how much water's made. You balance your carbon?
what?
You're gonna have to figure out what water's made too.
It's going to be a little bit more complicated.
You have to do that. You have to do 4 then.
Maybe.
Yeah.
Give it a shot. You guys are all welcome for this problem. Oh, yeah, we'll get there eventually. There's just a whole lot of chopping we can do here. Did all of that, was that fair chopping?
Yeah, that's good.
Oh, I gotta plug this in. Okay, here's to hoping I can extend the page without it blowing up. What was in front of O2? There we go. Or sorry, not yet. Who can just give me that answer so I don't have to type it in? What? 41?
Yeah.
Who agrees? Everybody? Okay, 41 point what? Okay, one of these is way smaller than the other one. Right here, right? So my limiting reactant is O2. Mass of my CO2, 41.25. So what's my excess reactant? Propane, C3H8. And now to find it, I can do it one of like 5 ways. Excuse me. I can make another picket fence for what? Grams of water. Okay, and I will always from now on, I'll start everything with my limiting. 50 grams of O2, 1 mole O2, 32 grams of O2. Then down here I had my 10 moles O2, and water. What was in front of water? Was it a 6? 8 mole H2O, 1 mole H2O, 18 grams of H2O. What's the answer to this? $23.5? Do people agree with Windsor?
Yeah, I agree.
All right, what would I do with these two numbers then? I would add them together, and I would get 63.75. And what would I do to that number? I would take 100 and subtract it, and I would get 36.25. Did I do my math right? Is that right?
Yeah.
Grams of C3H8 in excess. Okay, I don't care what way you use. This is one way. Here is another way. And shockingly, it's going to involve a picket fence. You're still going to start 50 grams of O2, but you're going to solve for grams C3H8. The reason you would do this is because this picket fence will tell you how much propane is used. You with me? And what would we do then? No, then you subtract it from the original amount I gave you. in Chapter 4, this will be the way you want to do it. And why in Chapter 4. But be at least comfortable with how we did this. So we still have 32 grams of O2 per every 1 mole of O2. Now, a savvy math student has been asking me for shortcuts. There really isn't a shortcut, but you might notice that this math right here was the same every time once we determined what my limiting reactant was. You're going to use that number multiple times, so if you want to just calculate it in the first step and write it down, as long as you know what you're doing, do it. If you don't know what you're doing, then do this entire process still. What was in front of the C3H8? Okay, now Murray asked me, he's like, can't you just reduce these? Absolutely. Then he said, which one's easier? It doesn't matter. Your calculator doesn't care if you divide 2 by 10 or 1 by 5. All right, now I would get rid of the 2 and reduce it to a 1 to 5 just because I wouldn't have to type in my calculator. But stoichiometry fixes itself because math is true. And I know that with every fiber of my being. And we said this was 44 a long time ago, didn't we? All right, so I'm going to reduce this to 1/5. And then someone do 50 times 44 divided by 160. 13.75. Oh, okay. Now look, this proves, well, I guess I should finish it. I'm sorry. This is how much I used. So what would we do? We subtract used from initial. What was my initial? 50. 50 minus 13.75 just happens to be 36. That's not a 6 at all. 0.25. Do you see that these two answers are the same value? That proves something, by the way. I can't scroll up. It won't let me. Oh, I can do this again. What this proves is that our original calculation, whatever was right here, that has to be correct. Let's try and scroll down. No, I know better. Okay? If you do it both ways, and I would not do it both ways. You have a lot of time to kill in your life. But if you do it both ways and get the same answer, then you know all of your answers are correct. Because you can't do one the wrong way and get the right answer, and do one the right way and get the other wrong answer. It is impossible. Okay, who feels like they're at a 3 out of 5 on their understanding? 3 or better, raise your hands. Okay, who thinks they're at a 5 right now? Windsor. Okay, good job. How did anyone just figure this limiting reactant out in their head? It's okay if you didn't, but you need 5 times the amount of oxygen as you do propane. Are you okay with that? That's what that's saying. 5 times the amount of oxygen is propane. Now, you got to be careful, but propane's mass and oxygen's mass are pretty close in the long run. Now, they might seem way off, but you have 44 and you had 32. Now, I know they're not super close, but when we're talking about multiplying 1 by 1 and 1 by 5, they're close enough, right? So in this problem, if I gave you equivalent amounts, you could, once you balance this, get a fairly good guess of what your limiting reactant would be. It would be the thing that had a 10 in front of it and not the thing that had a 2 in front of it. Did that concept make sense at all? Okay, I really want you to still do math, but sometimes you can reason them through. Okay, my gut says we should at least do one more. Let me pick one from your homework so you can at least kill two birds with one stone. We've had 2 people drop this class, so I finally have textbooks. Really. It doesn't matter. It was not from this class. One just kind of never really was into it, you know.
How do you even drop a class as far as a trimester?
I was shocked that their counselors let them. That's all I know. Because usually they say, heck no. Did anyone write down the numbers that are on the homework for Chapter 3? Okay, this is number 77. I'm sure this is assigned. If it's not, well then 79 is, but we'll switch it out. I have no idea what just happened. Somehow, like every tool up here is not doing the function it's supposed to. So you notice when I did a line tool, it's saved. When I'm doing this, it's going back a page. Like, but this one works eventually. I just lied. There we go.
I mean, if you run your head into a wall at times.
Yep. This little slate, it has the funniest bugs in it of anything I've ever owned. It just, whew. I don't know if funny is the right word actually, but whatever. Okay, 77 in your homework is very intense. It says the fizz produced when Alka-Seltzer tablet is dissolved in water is due to the reaction between sodium bicarbonate and citric acid. Okay, I'll continue reading. Then it gives you, because it has a heart, NaHCO3 and H3C6H5O7. Aren't you glad that it gave you that? It goes to, it's already balanced for you in the book also. It goes to CO2, but I'm going to see if you can balance it anyway. Plus 3H2O. It's getting worse here. Plus, oh boy, Na, and then this whole thing. C6H5O7.
Is that a 4 in front of your CO on this?
Over where? Right here? No, that's a H.
Oh.
NaHCO3.
It goes H3C6H5 with 2 H with bases?
Yes, this is an acid. Okay, so it has, oh my gosh, Thomas Davidson, you idiot. I got to remember not to change color. It has its H's attached to this anion, which also has H's in it. All right, now, just to save time, I'm just going to tell you the answers. You got a 3 here, a 3 and a 3. Oh, there's a 3 right there. That, I can't change colors. There's a 3 right here. So these are 1s. Okay, now the question says, are you ready? It says if you have 1 gram of each, so you have 1 gram of this and 1 gram of this. That's your givens. Okay? Okay, so A is what is just your limiting reactant, okay, which species. B, species is a thing in chemistry. It means all this crap is in a cup of water, and it's all broken apart, and each thing is called a species. B says how many grams of carbon dioxide. C, no, this is not. This is a neutralization reaction. Well, yeah, definitely. This is definitely not nothing. Grams of your excess reactant. Now, this problem, you will benefit on your excess by doing it the second way I showed you. Definitely not the first way I showed you. All right, I'm going to pause the recording for the next few minutes, and you all get a U if I forget to unpause it. Sound fair?
Very fair.
Well, the good news is you don't get a U. Okay, there's no way we're going to be able to do this problem in the next 3 minutes together. So this is number 77 from your homework. Try and get it done tomorrow. Well, you have a whole weekend, right? Monday we'll pick it up here and we'll start doing a lab. That's pretty fun. What's that?